but I can maybe get started on what we're going to be talking about today. So it's going to be about how we as humans are quite irrational sometimes, and what that actually means for revenue management and pricing, and how to properly account for that. So there's a lot of methods and a lot of myths around behavioral pricing, and we'll try to separate the good from the bad and just kind of outline what you need in order to account for the fundamental truth that humans are not always rational.
No surprises here, I guess. All right. Should we take a look? I think we should get started. Perfect.
Let's get started. Today's webinar, as always, with our founder Ingo. He developed the Binomics methods and has been in revenue management and pricing for over 12 years now. You'll be guiding us through the topic today. I'm Paul, head of sales. I'll be answering any questions you guys have in the chat and kind of moderate the Q&A at the end. So feel free to shoot away with any questions. I have a background in the consulting world. Maybe you want to go to the next slide just to kind of introduce the ones who don't know us to Binomics. We are a German software as a service company aiming to revolutionize data-driven price and revenue management. And we have developed a unique method that allows us to do so. We'll see it in action in this webinar today, and we're working with global companies in the FMCG, internet, telecom space. So that's why I was at the telco conference this week. And as you can see, we're also operating quite globally. So it's not something that only works here in Germany, but really around the world. So with no further ado, Ingo, let's get started on today's topic.
Thanks, Paul. And I think that it's already a good start into the topic. The pricing works around the world, and also behavioral pricing works around the world, because we're not so different after all. So there are some, and I think we actually have an example on that, some parameter differences, but the general logic applies everywhere where we've looked so far. And we're happy to talk about this topic today. So first of all, thanks for attending, taking the time to listen to our webinar. I hope we make the time worthwhile, and I'm very sure that we have something interesting to say. So today, topic behavioral economics, behavioral pricing is, I think for us, what we want to cover today is first give an overview of what the topic is, I think, and where the topic stands today. And I think what's for us important is also to talk about what we think the future of the topic is, how it will play out in our field in pricing and revenue management, and also what part we think we're playing in that field. So I think we have a lot of interesting topics. If you have any question, as Paul said, just write them in the comments. Happy to discuss them at the end of the webinar, and also afterwards. If there's anything you want to ask us, please just shoot it. And then without further ado, let's get started. So when we talk about behavioral economics or behavioral pricing, I think we need to first talk about what we actually mean by that, which I think it's helpful to start with an example, and that's already behavioral, I think, in nature, is I think with most of us being, or probably all of us being professionals in the field, we have an understanding of what it means to be irrational, to be behavioral. But the thing is, because of our nature, it's even if you know that you're not being rational, or it's difficult to be rational in a situation, it's really difficult to behave accordingly. So here's a really good example. So these two arrows here at the right side, and most of us have probably seen this example, is the lines in the middle, they're equally long, right? But because the arrows show in different direction, it's really hard to see that they have equal lengths. So the natural thing for us is to see them at different lengths, and there's an enormous amount of examples on our playing with our visuals and other properties of our perception, where it's really easy to trick how we see reality and exploit it for whatever reason. So this is an example. So I think the major takeaway is, it's even if you know you're not being rational, it's really difficult to do anything about it. And the reason why we have working, although we know we are irrational in many cases, there's also a good reason why most of our models that we use in pricing, most of the techniques based on these models assume rationality. So, and to understand that, I think it's very helpful to be more specific with the difference. So on the left side, Star Wars fans among us know him, Commander Data, Android. So he's a machine. He can be fully rational. And from economics, we know being rational means we're maximizing utility. If we want, we can look at all alternatives and we make consistent decisions. So if we prefer A to B and B to C, then we also need to prefer A to C. So these are things, that's what it means to be rational, but it's easily written down, but it's really difficult to actually do that because we all know that we are mostly humans on the right side here. That means it's really difficult to be rational. And instead of looking at all alternatives, going through the utility optimization exercise, we work with simple heuristics. We'll show some of these on the following slides. But this is really the difference. And I think what's important for us, and this is something that we've actually spent quite some time on lately, is to understand why that actually is. So most of the tools that we use in pricing, like price elasticity, value pricing, and so on, they're fairly rooted in classical economics that use calculus and other methods to do the work, and these are really based on the fact that you need to simplify methods. So you have a concept like a price elasticity, where you look at the demand function and convert it to just a single number, -2, for example. That really serves the purpose of simplifying the analysis. If you work with a price elasticity of -2, everything is really easy. The problem is that typical demand functions don't have a constant price elasticity. So if you have something like a linear demand function, elasticity changes along the way. And if you work then actually with a simple constant elasticity, it's very likely that you're making a poor decision. But or another example would be something, for example, in value pricing, where you say you have something like a pen like this one here, and the question is, what's the cap? How much is that worth? You think, okay, that's maybe 5 cent value to the customer. Then actually that means that's an average number across a set of customers. And of course, none of us is really average. Together there is an average among us, but none of us is average. So someone puts a value of 2 cents on it. Someone has a value of maybe 17 cents. So, and that actually matters. But if we simplify it, as we do in value pricing, for example, we just look at the average, and that allows us to, on the one hand, to actually work with these tools, but on the other hand, it also takes away lots of the complexity that might be useful for actual decision making, and that's something where we at Binomics are working on. So this is, I think, important to keep in mind, that when we look at behavioral pricing, knowing that often we work with an assumption of simplicity, that this oversimplification serves a purpose, and the purpose is that you can work with tools like price elasticity, value pricing, and so on, that are at least implicitly based on the assumption of rational homo economicus as an underlying model. So this, I think it's an important starting point here. And when we then turn towards behavioral economics more broadly, or more specifically than behavioral pricing, there's a huge literature on specific effects that have been discussed in the literature. Lots of examples, things like substitution, where you have a complex problem that's too difficult to solve for most of us, and that's replaced by a more simple problem. So for example, when you have a car that consists of, I don't know, 200 different features that make up the car, people will not look at these 200 features, but they will look at brand and the strength of the engine, 2 or 3 other things, and that's what they base their decision on. So they, and we all do that, strongly simplify a problem instead of solving the complex problem where they have to look at 200 features of a vehicle, for example. So there are tons of examples like this, and I think they have been largely described. But what's lacking a bit in our view is how can we actually work with these examples? How can we, as pricing professionals, best work with them? How can we particularly parameterize them and use them best for pricing decisions, setting up our portfolio, and so on? And that's what we want to talk about here. So let's start with a very simple example. Probably most of us have seen it. So we're looking at a portfolio of 2 wine bottles, a cheap one at 10 euros and a more expensive one at 30 euros. And in this case, and this is based on a real experiment that has been run, most customers wanted to buy the cheaper one because people are reluctant to buy the most expensive product and say, okay, if there are only those 2, then I'll go for most of them said, I will go for the cheaper one. So we have 60-40% towards the cheaper bottle A. If we then add a third bottle that's more expensive than B at 50 euros in this case, that serves as a decoy. And what it does psychologically for most people is that now B doesn't look that expensive anymore. And many people switch from A to B, and that would be irrational, right? It violates one of the axioms that we had in the beginning. So they have to, your preferences have to be consistent. If you prefer A to B, you should also prefer A to B if there's C added. So that wouldn't be rational. And that would be a case where you say, okay, people who switch from A to B because C is now added, they're not behaving rationally. So this is one of the key observation, or one important observation. And that's also a case that's been used by many pricing models. Often if you have a good, better, best model that follows a similar logic. So you have a very expensive product at the top to make the middle product look more cheaply. And then often what you see is that more people go from A to B than you would have when there are only products A and B. But this is actually, if you want to optimize your portfolio, not the only question that you need to answer. Of course, immediately you are looking at cases where, so would it make sense to have 10 and 30 euros, or would it be better to have 15 and 30 euros, or maybe 10 and 20? So there's more than just this basic effect to look at. So let's look at this example in a bit more detail. Just give me 1 second. I need to switch the screen for this. Yeah. Paul, can you see my browser now?
Yes.
So so we took this example. I just took this example and put it into our pricing solution. So this is our Binomics tool, and we have the 3 bottles: good, better, and best. They have different qualities that we said. So this has the good quality, this has the better quality, and this has the best quality. This is excluded, so no customer can see this product. So we're only offering these 2 products. They have prices 10 and 30. And we could look at different price ranges here from 5 to 15, 20 to 40, and so on. And when we show this, let's just move this here, to the virtual shoppers, what we're now doing is we have this offer of the 2 bottles, just as on the slides before. We can show this to a group of virtual shoppers, as we call them, and we have different sales units for these two products. And if you look at the shares, this is exactly the 40 to 60 market share that we had previously on the slides. So in this example, what we did is we set up the model such that all the customers of this product here in the example are fully rational. So they don't have any behavioral effects. So we can look at that. We could also look at things like demand curves, you see. So if I change the price, people will buy more or less. Revenue, we have price elasticities along the line. So we have full transparency on what will happen in this market with these two products. If I now add the third product that I didn't show previously, you should save this, then I will see, and because I still have not included any behavioral effects here, so people are still fully rational. So, and then I see, as in the slides before, that still most people, because they're rational, they don't switch from A to B just because I added this best product here at the bottom. So I have most people 55% buying the good product, then a bit fewer 37% by the better product, 7% by the best product. So, and these are still fully rational. And if I now tell these, we call them virtual shoppers or virtual customers, if I now tell them to be irrational and have a higher preference for the middle product here, then what happens is that now people switch from the best and some from the good to the better product. And they have now a strong preference for the middle. And if I look at these three cases in comparison, what I see is just what I had before. So I have the 60-40 here, then this case, if everyone is rational, and then this case here, if people behave like all of us, or most of us, and fall for or have a stronger preference for the middle. And that shows us how this works. What I haven't done, and I won't do because of the time that we have left, is, of course, I can also change the prices in these. And if this was my shop, those are my products, I could use this tool, for example, to make best use of this middle preference effect here. So I can not only know that I can have a different preference, but I can actually optimize using it. Just to conclude here, so we have the highest profit in the case where I simulate that people behave like real people. So this just shows you how to actually work with these behavioral effects. This was just, I think, a very simple example, but of course, these effects can also be used more broadly, and all kinds of effects can be used. Let me switch back to the presentation. Paul, can you see it again?
Yes, I can see it. Just need to go to presentation mode.
Yeah, so just to conclude on this here, so this was the example we showed, and we can see the difference for the Homo economicus, for the Homo sapiens, that we showed. And I think what's important, the behavior of the Homo economicus can be measured, and we can also measure how the behavioral effect changes here, the take rates or the preference of these people for the different products, so that you can actually make best use of these behavioral effects. This was just one example, so a very famous one, but just one out of many. And of course, many other features can be modeled as well. So just to go through them, so there are things like that most of us have seen in different products, default nudges where you say, okay, this is the best value for money, or most people buy this product. All of these have differing effects and can be used to optimize pricing. Things like power of free, people tend to buy products where something is free, and so on. So all of these can be modeled. All of these exist. There's huge large literature on these effects, and they can also be used to optimize the offer. So let's look at 2 more examples. And I think what's important here is that it's not enough to know the effect, but to actually work with it, you need to have a proper parameterization of the effect. So you need to know how strong is, in this example here, the power of free. And then you need to have a model that's capable of applying this insight and to help you optimize your offer considering the effect. So in this example, what we did is we asked 2,000 real customers. In case A, we showed them 2 offers. Those are 2 telco plans. So in this one is they got 3 GB for €1 per month, and then from month 6 it costs 10. In this example, it costs or you got 5 GB for €1 in the first 6 months. So the first 6 months cost the same, and then after 6 months it went to 15. And then in the second offer, everything was the same, but except for the €1 you had to pay for this plan, you got the first 6 months for free. And if you compare these 2 cases, then in the second case, this 5 GB plan is more attractive than the 5 GB plan in the first. And you would expect people to, in the case B, more people to go to the 5 GB plan. But what you see here is, so both the Homo economicus and the Homo sapiens would prefer the 5 GB in case B. But what we saw is that we looked at this in different countries. Here are 3 examples: Spain, France, and Germany. What you see is that actually the share of B dropped in Spain and in France. Only in Germany you have the effect that you expect. And that's peculiar. So there seems to be cases where customers become suspicious when they see this effect, because if they get something for free, most people, or increasingly not large number of people, think that there is some hook, and they become suspicious and don't go for the free product. So the effect, what we see also in our work, is it exists, but you have to be very careful in parameterizing properly these effects to make best use of them. And that's also what we do very frequently in our work. Another example, I think, that most of us are familiar with. So this is a chocolate snack. And we did a basic customer survey asking, so it was Gabo Granger van Westendorp survey where we asked people, would you buy this at certain price points? And what we saw is that, of course, with the increase in price, demand goes down, and at the €1 mark, you have a significant price threshold. In this case, you have about 35% sales that were lost, going from 90 cents to €1. So this is often what we see in surveys. But when we then looked at that same product, not in isolation as it was in the survey, so people were just asked about this product, would you buy it at this price, and so on. When we looked at the same product in the competitive context, and each dot here is the price sales combination in 1 week. So these are sales, so they're normalized, and at the lower price, of course, you sell more than at the higher price. But the important thing here is that you do see, when you do the math, a slight price threshold, but it's much weaker than what the survey suggests. And this is because in this case, so the price threshold exists in reality, but most people are not asking themselves, do I buy this chocolate snack or nothing at all? But the more relevant question is, do I buy this snack or some other snack? And therefore, the decision the question of the price threshold becomes less relevant because often the trade-off is between this particular product and other products. And these are things that I think from our experience are very, very important to know when you're working with these behavioral effects. If you do a simple survey in isolation, just looking at a specific product, the result is much, much different than what you get in a full market. And this we see for many, many other effects as well, that if you just looked at them in isolation, they're quite different from what they are in a real scenario where customers have more alternatives than the focus that you have, be it a price threshold here or like a good, better, best offer. If you have a good, better, best offer, but there are competitive products around it, then also this middle preference effect becomes much, much weaker. So these things are really important. So just knowing that the effect exists and knowing its magnitude is not enough from what we see. The last step is also being able to properly model the effect so that you get the right preference. And if you are deciding, if you need to decide, do I go above the price threshold or do I stay below the €1 here, that knowledge, of course, is super important and makes the difference between a happy year and a less happy year in many cases. And incidentally, those are exactly the questions that can be answered with very high precision using our solution. And that's what we spend most of our time on. So to conclude, I think same as in medicine, behavioral effects work. So it's a good medicine, but too much of a good thing becomes difficult. We all know these examples. If you fall asleep in front of the TV, if you wake up, you have an ad like that. And they are, if you look at it in detail, they make full use of behavioral effects. And from our experience, this is often way too much. Thanks for your time, Paul. I think we have some questions.
Yeah, that's right. I was already chatting a little bit in the chat function with some of our guests today. Felix, for instance, asked, the behavioral literature has documented many different biases. How do you decide whether a bias should be part of the formal model or not? I answered a little bit. We include all relevant behavioral effects that we can measure. Can you add a little bit more color to that answer?
Yeah, so of course, that's a very good question, and it's not easy in every case, but many of these effects they show, like for example, price threshold. That's something that you can see in the data. Also, to what extent it exists, but I think it's two things. One is experience with what effects are relevant in a situation, and the other is being able to measure what effects are relevant in a situation, and that can be based on, for example, sales data. Where do you get an effect? And also looking at surveys, for example. So there are different ways to determine if these effects exist. So, for example, we had I think on the slide before, the highlight where you have, for example, like a good, better, best, or you have 4 products and one is highlighted where you say most customers buy this product. So you could A/B test and move that box to a different product and see how that affects behavior. And these are techniques you can use to assess the relevance of a certain effect.
Great. And then Farhana was asking what other factors are modeled in elasticity apart from price, especially if you're in a retail environment.
So traditionally, like and I think that's what most people do, is if you have like a regression-based model on elasticity, they will look at just the basic price elasticity in addition to further options include like looking at cross effects with competitor products, looking at the effect of price thresholds or promotions, for example. But in traditional models, everything we've seen, I think, is and that's what I was talking about in the beginning is very much oversimplifying. So if you say we have a price elasticity of -2 and then we have a price threshold and it goes from -2 to -3, for example, that's not how elasticities work. And that's why we have the model that we just briefly showed here is that what it does is we create what we call virtual customers or virtual shoppers, and you can give them, or you can essentially give them preferences for certain products. These can be parameterized based on sales data, different other data sources. And then they make purchasing decisions. And in these, you can turn on and off, as I showed in the examples, certain effects. And then you see how price elasticity reacts to such changes or to the different effects. And also how it reacts to, for example, changes in competitor products and so on. So you have full situational awareness around your decision.
Great. I think that was it from the questions. If you have any more questions, feel free to send them in the chat now. Otherwise, you'll also receive the webinar as a recording in your inbox, and happy to answer any questions by email that you have. Ingo, do you want to go to the next slide maybe? Just looking at our upcoming webinars. We have one with our friends at Viper. For everyone interested in, especially in the consumer goods industry and innovation, we're going to be part of the Innovate 2.0 Summit, and then we'll also be at the European Pricing Platform, explaining a little bit how our AI works in pricing and revenue management. So stay tuned for that. Follow us on LinkedIn and check your inbox for any updates. And yeah, hope to see you at the next webinar.
Same here. Always a pleasure, and I'm looking forward to the next. And have a great and peaceful weekend. Thanks.
Thanks so much, Ingo. Bye.